Hello friends, so today's video is going to be about systems of equations. It's just continuing our Unit 2 overview. This is the fourth part that we have done. And we're going to talk today about applications, which just basically means word problems because it's ways that this math applies to real life. So it tells us the direction or the instructions on how to solve each problem like usual. Define your variables, set up two equations, solve. So let's take a look at our first question. Marcy bought a total of 20 used books and CDs during a yard sale for a total of $54.50. If books cost $1.50 each and CDs cost $5 each, how many of each did she buy? Okay, so when you're doing a word problem, I like to break it down one sentence at a time. So we're going to start with the first sentence. And it says, she bought a total of 20 books and CDs for a total of $54.50. So we don't know enough from this one sentence to write about the cost, but we do know that she bought a total of 20. So books plus CDs has to equal 20. Okay, that's one thing that we know from this sentence. Now, we know the total cost, but we don't yet know from this sentence anything else about it. So now let's look at the next sentence. If books cost $1.50 each and CDs cost $5 each. So now we know the price of each thing and can write that one. So books cost $1.50, so it would be $1.50 for every book that she bought. So 1.5 times B. And then CDs cost $5. So add $5 times every CD she buys, and that would give us the total amount of money spent. And we know that that was $54.50, which is 54.5. So you can use any method that you choose. We've used graphing, which probably doesn't make sense in this situation, substitution, or elimination. My personal favorite is substitution. That's how I'm going to show this. But as long as you get the right answer, you could definitely use elimination if you prefer that. I'm going to take this equation and make it B equals 20 minus C, so that now we've solved for B, and we can plug this in for B here. 1.5 times 20 minus C plus 5C equals 54.5. Then we will distribute. 1.5 times 20 is 30 minus 1.5C plus 5C equals 54.5. Then we will subtract 30 from both sides, and I'm also going to combine like terms on the left side. So we're going to get 3.5C equals 24.5. And then we're going to divide that to get 7. So we will have C equals 7, meaning she bought 7 CDs. But the question says how many of each. That looks like I marked it out. How many of each did she buy? So we need to know also how many books. We know that she bought 20 in total, so books are going to be 13. So you could write 7 CDs and 13 books. Now, something we didn't do here was define our variables. So you should also say B equals number of books and C equals number of CDs. All right, now for the fun part. We are going to do systems of 3 equations. And this is a whole process, and it gets a little bit long and a little bit confusing, okay? So you really have to keep things organized really well whenever you do systems of 3 equations. So let's just follow our directions here. It says to choose 2 equations in which you can easily eliminate, okay? So not substitution, eliminate a variable. And then once we eliminate that, we'll call this new equation after the elimination equation A. So if I'm looking at these, the x's have a 2, a 5, and a 3. None of those are super easy to eliminate. Here we have 6, 1, and 1 on our y values. So the 1 and 1, if I just changed one of them to a negative, those would cancel. So that seems easy. Over here I have a 9, a 2, and an 8. And I think that the y's are my easiest ones. So I am choosing these two problems to make equation A. So just to remind myself what I used, that's what I'm going to do. So then underneath of here, remember to stay organized. So I'm even going to label this for you. This is my work to get equation A. So I'm going to do 5x plus y plus 2z equals 10. And then I'm going to multiply this whole thing by -1. So I'm going to get negative 3x minus y plus 8z equals positive 28. Make that look more like a z. Then I'm going to add the two equations together. 5 plus -3 is 2x. Our y values cancel. And then 2z plus 8z is plus 10z equals 38. So equation A is going to be 2x plus 10z equals 38. All right, so we did step 1. Step 2, eliminate the same variable from a combination of the equation you didn't use and one of the ones you did. We will call this equation after the elimination equation B. So for equation B, I have to use the one that I did not use, and then I can choose either of the other two. So it really doesn't matter that much. Sometimes it will make more sense because it'll be easier to eliminate it out of certain ones, but we're going to do these two for B. Just honestly, there's no real reason. It's just the one that I'm picking. And we have to eliminate the same variable. So we've got negative 6y and positive y. So I'm going to multiply this whole equation by 6. And that will give me a positive 6 and a negative 6 to cancel out. So we'll do our work for equation B here. And that is going to include the first equation on the list, 2x minus 6y plus 9z equals -8. And then we are multiplying the middle equation by 6 to get those y's to cancel for us. So we will get 30x plus 6y plus 12z equals 60. And then add those up. So 32x, y's cancel, plus 21z equals 52. So equation B is going to be 32x plus 21z equals 52. Okay, so we did step 2. Now it says to put equation A and B together and solve that system. Okay, so equations A and B, I am going to use the substitution method on these. Actually, no, I think I'll continue using elimination. That way you're only using one method the whole time and you don't have to get confused about it. So here's going to be the work for A and B together to solve that system of equations. I'm going to leave B as it is, and I'm going to change A. I'm going to multiply it by -16 because that'll get rid of the x's. So we've got 32x plus 21z equals 52. And then we're going to we want to multiply this by -16. So we'll get -32x minus 160Z equals negative 608. So then whenever I add those together, my x values cancel. 21 plus negative 160 is negative 139. Z equals 52 plus negative 608 is going to give us negative 556. And then we should get Z equals 4. So we have gotten one of our variables, finally. So then to find x, we have to plug 4 into either A or B equation. So go back over here, and it looks like equation A has the smallest numbers in it, so that's how I'm choosing. It doesn't really matter, though. You can put it into either one. So equation A is what I'm choosing to use. 2x plus 10z, which is 4 now, equals 38. So 2x plus 40 equals 38. Subtract 40 from both sides, 2x equals negative 2. X is going to equal negative 1. So now we have two of our variables. And finally, our last step is to plug both of those into any of the 3 original equations and solve. So we did step 3. We're on to step 4. So we'll just use the very first equation just because it doesn't matter. 2 times negative 1, because x is negative 1, minus 6 times, we don't know yet, we have to solve for y, plus 9 times 4 equals negative 8. So negative 2 minus 6y plus 36 equals negative 8. Negative 6y plus 34 equals negative 8. Subtract 34 from both sides to get negative 42, and y is going to equal 7. So when we write our final answer, it's an ordered pair, but it has 3 different values in it. And you put them in order x, y, z. So x is negative 1, y is 7, z is 4. So this is our actual answer in its correct form. Okay, for these word problems, there's a reason I give you half a page to answer them. You have to read the word problem, write 3 equations from it, and then solve a system of 3 equations. So that's what we're going to do. The theater sells 3 types of tickets: general admission, senior citizen, and child. Mark bought 9 general admission tickets, 2 senior citizen tickets, 3 children's tickets, and paid $170. And Sarah bought some tickets, and Kyle bought some tickets. So we need to find the cost of each type of ticket. So let's think about what each person's cost looks like. So if we are just talking about Mark, so Mark bought 9, general admission, blah, 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 and paid this much. So if we make our variables be, let's just keep them maybe x, y, and z, because that's just easier to look at in my opinion. So if we make x the general admission, and it will represent the price, then senior citizen, so we'll put senior cost is y, and the child cost will be z. So for Mark, he bought 9 general admission, so we know that 9 times x plus 2 senior citizens, so 2y, and 3 child tickets, so 3z, equals $170. Then we're going to do the same thing for Sarah. Sarah bought 5 general, 4 senior, and 7 child. and she paid $173. And Kyle bought 4 general, 1 senior citizen, so we don't actually have to put the 1, and then 6 child tickets, and he paid $116.50. So now we have 3 systems of equations, or 3 equations in our system, and we need to solve. So we're going to choose 2 of these equations to make equation A. So I see this y that does not have a coefficient. And so in my opinion, that one would be the easiest to manipulate because I can multiply by like the smallest number to get it to work. So I'm going to multiply, I'm going to use the bottom 2 to get our, actually no, I'm going to use the top one and the bottom one to get A because I only have to multiply by 2 to get the y's to cancel. So the smaller numbers you multiply by, the smaller your numbers will be as you're working. So anyway, I'm going to multiply the third equation by -2 to get my y's to cancel. So here is our work for equation A. We have 9x plus 2y plus 3z equals 170. And remember, we're multiplying the other equation by -2. So -8x minus 2y minus 12z equals -233. Oops. And then we're going to add those together. So we get x, our y's cancel. 3 plus -12 is -9z equals -63. So equation A is going to be x minus 9z equals -63. All right, now we have to choose 2 for equation B. So remember, we have to use the middle one because we did not use it before. So we're going to use the middle one and the bottom one because we have to eliminate the same variable. So we have to eliminate the y values. So if we do these 2, then we can multiply the bottom one by -4, which is pretty simple, and get what we need. So this is going to be B. So let's go here and do our work for equation B. The top or the middle equation is our first one. So 5x plus 4y plus 7z equals 173. Then we multiply the bottom equation by -4. So we're going to get -16x minus 4y minus 24z equals -466. And when we add those together, 5 plus -16 is -11x. The y's cancel. 7 plus -24 is -17z. And then 173 plus -466 is -293. All right, so that is equation B, and even though I put the B over here, I'm going to rewrite it right here so that I have room. So it was from this one and this one. B is -11x minus 17z equals -293. So you can use elimination or substitution. I'm going to use substitution to solve for A and B this time, because just to show you a different way, I guess. So I'm going to take equation A, well, here, A and B. This is our work for that. Equation A can be rewritten as x equals -63 plus 9z. So that's what I'm going to plug into equation B. So -11 times -63 plus 9z minus 17z equals -293. So I'm going to distribute that negative 11 to get 693 minus 99z minus 17z equals negative 293. Subtract the 693, then combine like terms to get negative 116z equals negative 986. And then whenever we divide that, we're going to get 8.5. So z is going to equal 8.5. We have found one variable. So then we can plug our z value back into this equation to figure out what x is. So we have x equals negative 63 plus 9 times 850. And you can plug that straight into your calculator if you want and get x equals 1350. So that is another one of our variables. And then our very last step is to substitute both of these in for any of our original equations. It does not matter which. And then solve for y. So I'm going to pick the third one because y doesn't have a coefficient. So that makes it seem easier to me. So we've got 4x, so 4 times 1350, plus y, which we don't know yet, plus 6 times z, which is 8.5, equals 116.5. So 4 times 1350 is 54, plus y plus 51 equals 116.5. So we are going to end up, when we add the 54 and 51, then subtract it from the other side to find that y is equal to 11.5. So our final answer should be written as, it wants to know, find the cost of each type of ticket. So we should put general admission, cost, that was our X value. So that's $13.50. Senior admission was our Y value. That's $11.50. And finally, children admission was Z, so $8.50. So that's our final answer is written like this. Because in this one, they actually have values. They're not just like an ordered pair like they were in the last one. So we're going to do another word problem together because that is a lot of work, and I understand that, and it's hard to keep it straight. So we'll do one more. All right, so you can pause the video here and read the problem for yourself once real quick. All right, so let's take this just a little bit at a time. Jamie has a collection of 78 nickels, dimes, and quarters. Stop there. We have nickels, dimes, and quarters. I'm going to call them N, D, and Q this time. Nickels, dimes, quarters. Nickels is the number of nickels, or N is the number of nickels. D is the number of dimes, and Q is the number of quarters. All right. He has a collection of 78 total. So that means one of our equations is N plus D plus Q equals 78. All right. Then we know that it's worth $12.40. So we know the value of nickels, dimes, and quarters already. A nickel is worth 5 cents. So that would be 0.05 times the number of nickels that you have. And then dimes are worth 10 cents, so 0.1, let's write that different. 0.1 times the number of dimes, and then 0.25 times the number of quarters. When you add all of that up, it should total $12.40. Okay, then it says, if the number of quarters is doubled, the value becomes $22.15. So this one is still a value-based equation, but our quarters, we're going to have twice as many. So what that would look like is, let's just do this little section, okay? We would have 0.25 times 2q because we'd have twice as many quarters. So this is going to simplify to 0.5q. So what we're going to do is, instead of all of that, we are going to write 0.05 in, because the nickels would stay the same, the dimes would stay the same, but we're going to say that our quarters are now worth 50 cents because that's the same as saying there's twice as many. And if they were, this would equal 22.15. So now we have 3 equations that we can use to solve. All right, so step 1, choose 2 equations to make equation A. Really, any of them, like, they're kind of going to be the same. I would not recommend pairing these 2 together. I would pair the first one with the second one, and then to find B, I would pair the first one with the last one, because the first one doesn't have any coefficients. It's going to be the easiest to deal with, so make it your common equation. Okay, so let's do equation A down here at the bottom. And we'll just go ahead and use these 2 for equation A. We will multiply the top by negative 0.1, because I think multiplying by 0.1 is going to make the easiest change in the numbers. So the top equation, we will multiply by negative 0.1. All right. Negative 0.1n minus 0.1d minus 0.1q equals negative 7.8. And then our second equation stays the same. So 0.05n plus 0.1d plus 0.25q equals 12.4. Then we add them together. The d's we know are going to cancel. So negative 0.1 plus 0.05 equals negative 0.05 n. And then negative 0.1 plus 0.25 is going to give us plus 0.15 q equals negative 7.8 plus 12.4 is 4.6. So this is equation A. Then we need to come up with equation B. So we will use the top and the bottom to make B. And actually we can multiply it by negative 0.1 again, and it'll cancel the d's out again. So come up here for equation B. And we're going to get negative 0.1n minus 0.1d minus 0.1q equals negative 7.8, because we had to divide, or we got to use the same multiplication in the top one. And then the bottom equation here is going to be our other one for B. So 0.05n plus 0.1d plus 0.5q equals 22.15. We're going to add these together. We know the d's will cancel. Negative 0.1 plus 0.05 is negative 0.05 n. And then we're going to get plus 0.4q equals 14.35. And that is equation B. So then we want to put A and B together. So I'm going to rewrite them so that we can look at them side by side. Equation A is negative 0.05n plus 0.15q equals 4.6. B is negative 0.05 n plus 0.4 q equals 14.35. So I'm noticing we have the same variable for our n's, or same coefficient for our n's. So we can just change the sign of one of the equations and be good to go. So I am going to multiply b by -1 and change all the signs. So I'm just going to go in here and change my signs. The first one changes to positive, the second one becomes a negative, and then our number on the right side becomes a negative. So we just multiplied everything by -1, and our n's cancel. 0.15 plus -0.4 equals -0.25q equals 4.6 minus 14.35 equals -9.75. Then whenever we divide that, we're going to get that the quarters there are 39 of them. So we have got one variable finally. Then we can plug our q value into either equation A or B and find the value of n. So we can choose either one. Let's choose B. I don't know why, just for fun. So if we plug 39 in for Q, so I'm going to do that over here. Negative 0.05 n plus 0.4 times 39 equals 14.35. Whenever we evaluate this and do the math, we're going to get that n is equal to 25. And finally, we will plug both of these values into any of the first equations and find the value of D. So we know that n plus D plus Q has to equal 78. So 25 plus D plus 39 equals 78. So that means that D has to equal 14. So the number of nickels is 25. The number of dimes is 14. The number of quarters is 39. And we have our answer. All right. Thank you guys for watching.